In today's video, we are going to learn about a topic which is known as regularization. Now, you would be wondering what exactly is this regularization? Regularizations are techniques used to reduce the error by fitting a function appropriately on the given training set and avoid overfitting. In my previous video, I have explained the concept of overfitting. In overfitting, we have low bias, but we have high variance, which means that we have low training error. That is, the error which occurs during the training of the data is very low, but it fails to generalize to unknown data points. That is, we have a very high testing error. So regularization tries to penalize our error so that the error is reduced. Regularization is a technique used for tuning the function by adding an additional penalty term in the error function. The additional term controls the excessively fluctuating function such that the coefficients don't take the extreme values. So basically, we are trying to reduce overfitting in our data and we are trying to control our coefficients. We do not want our coefficients to take extreme values. Hence, we are penalizing our coefficients using the square term and mod term. Now, let us look at the different types of regularization. So, there are two types of regularization. There is LASSO regularization, which is also known as L1 regularization, and we have rich regularization, which is also known as L2 regularization. Now, let us look at what exactly this LASSO regularization does. LASSO stands for Least Absolute Shrinkage and Selection Operator. It is a type of linear regression which uses shrinkage. Now you would be wondering what exactly is this shrinkage? Shrinkage is where data values are shrunk towards a central point like the mean. So the basic idea is to find the true population parameter. What shrinkage does, it tries to shrink the data so that it is close to the mean value. This particular type of regression is well suited for models showing high levels of multicollinearity. In my video on assumptions of OLS regression, I have explained what exactly is multicollinearity. Multicollinearity is something very specific to multiple linear regression, wherein two or more independent variables would be correlated with each other, which will lead to biased estimates of our linear regression model. Now, L1 regularization adds a penalty equal to the absolute value of the magnitude of coefficients. Now, this is our loss function. So, our error is nothing but the difference between the actual values and the predicted values. And we are penalizing this. How are we penalizing this? By adding an extra term, which is nothing but lambda into summation I is equals to 1 to n wi. Wi is nothing but the values of the coefficients. Now this lambda that you see over here, if we put the lambda as equals to 0, then what will happen? We are again left with our OLS estimate. Now, if we increase the value of lambda, there is a high probability that we would encounter something known as underfitting. Underfitting stands for high variance and high bias, wherein our training data is also having a high error and their testing error is also very high. So sometimes when we use lasso regression, we may end up losing certain coefficients. Certain coefficients would end up becoming 0. Now let us understand ridge regression. Ridge regression is also known as L2 regression. It adds an L2 penalty which is equal to the square of the magnitude of coefficient. So initially we were adding a penalty multiplied by the mod of the coefficients, but here we are taking the square of the magnitude of the coefficients. Rich regression uses a type of shrinkage estimator known as rich estimator. We have studied about shrinkage, wherein we are trying to shrink our data towards the mean. The rich estimator is especially good at improving the least square estimate when multicollinearity is present. Multicollinearity is a condition where your two or more independent variables are correlated with each other. And the formula for rich regression goes something like this. So you have summation I is equals to 1 to n yi minus h theta xi the whole square. This is nothing but our mean squared error. We are adding a penalty which is lambda into summation I is equals to 1 to n theta I squared, which is nothing but the square of the magnitude of the coefficients. And if the lambda value is equal to 0, we are left with our OLS regression. If the lambda value is too high, we are going to encounter something known as underfitting. So this was lasso regularization and ridge regularization. I hope everyone is clear with the idea of L1 and L2 regularization and why we use L1 and L2 regularization. Thank you.